Okay, today we're going to work on simplifying radicals. This is just where we left off at the end of class on yesterday. And remember, I told you yesterday, it's very important that we learn our perfect squares because everything that we're going to do with simplifying radicals require that we focus on our perfect squares. So as long as we know those perfect squares, then this job for us should be fairly easy. Whenever we're renaming, we're going to make sure that we're using one number that is a perfect square, but it has to be smaller than the given number. So let's look at an example together. Okay, so I have the square root of 48. When I look at 48, we know that 48 is not a perfect square. The perfect squares that we should start with, we have 4, 9, 16, 25, and 36. Those are all of your perfect squares that are smaller than the given number. So when I look at 4, my thoughts are, can 4 go into 48 an even number of times? The answer to that question is yes. 4 times 12 is 48. And I'm going to split this up. Square root of 4 times the square root of 12. Now, we should know that the square root of 4 is 2. So what I have is 2 square root of 12. Whenever we're done, we should always check the number that's under the radical. In this case, it's 12. I'm going to take 12, go back over here to my list of perfect squares, and 4 and 9 are both smaller than 12. Can I rename 12 using a 4 or a 9? The answer is yes. 12 is 4 times 3. So now my problem is 2 square root of 4 times 3. I split it up. 2 square root of 4 times square root of 3. We know again here the square root of 4 is 2. So this becomes 2 times 2 square root of 3. And 2 times 2 is 4. So our answer is 4 square root of 3. We don't have a perfect square smaller than 3 other than 1. So there's nothing else we can do with the 3. So your answer is just 4 square root of 3. Now, some of you are thinking larger than 4. Okay? When you're looking at these squares here, I have 16. And I know that 16 can go into 48. So I'm going to make this 16 times 3. 16 times 3 is 48. So I split it up. Square root of 16 times square root of 3. Square root of 16 is 4. And I get 4 square root of 3. Once again here, square root of 3 don't have any perfect squares that are less than 3. So this is my final answer. So what you see here are two different methods to solving or simplifying the square root of 48. Either method gives us the answer 4 square root of 3. Okay, now let's work with some numbers a little bit larger. So we're going to focus on perfect squares. So I'm going to come off to the side. I'm going to do 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. And now we're looking at 150. So we're trying to use one of our perfect squares to rename 150. Well, if you know your divisibility rules of 5, you know that 150 ends in a 0 and 25 ends in a 5. So 25 times 6 is 150. So I'm going to rename it 25 times 6. When I rename this as 25 times 6, that's the square root of 25 times the square root of 6. Square root of 25 is 5. And we cannot simplify square root of 6. So your answer is 5 square root of 6. Okay, now let's look at number 2. On number 2, you have the square root of 128. Well, it ends in an 8, so that means it's even. 4 is even. And you can always see if 4 can go into 128. and it can 32 times. So you can rename this as 4 times 32. The square root of 4 times the square root of 32. That gives me 2 square root 32. Now with 32, I'm not going to waste my time with 4. I'm going to go larger. I'm going to do 16 times 2. What I need for you to do is to start thinking larger. Square root of 16 times square root of 2. Square root of 16 is 4, so it's 2 times 4. Square root of 2. 2 times 4 is 8. Square root of 2. That's your answer for 128. Now, and there's another way that we could actually do 128. You could have renamed 128 as the square root of 64 times 2. And that's the square root of 64 times the square root of 2, which gives you 8 square root of 2. Okay? Like I've been telling you all year, it doesn't matter to me about what method you use, as long as you have work to justify your answer. Okay. 3, we got the square root of 8. Well, the perfect squares are 4, 9. I can stop because 9 is already greater than 8. So I'm going to rename 8 using 4 times 2. That's going to be square root of 4 times square root of 2. And that gives me 2 square root of 2. 27, can't use 4, but we can use 9. So we rename 27 as the square root of 9 times 3. Square root of 9 times the square root of 3. Square root of 9 is 3. Square root of 3. And this may seem hard right now, but the more we practice with it, the easier it's going to get. But what's going to really help is making sure that you know your squares. Now, looking at number 5. Number 5 is a little different, okay, in the fact that I've thrown in some variables. So what we're going to do is we're going to split this up from the beginning. Okay, we're going to have the square root of 28 and the square root of k squared. We can rename 28 as 4 times 7. So it's the square root of 4 times 7. Square root of 4 times the square root of 7. Now, this step, you can leave this step out if you like, and you can just simplify it from here. The square root of 4 is 2, and we're going to leave it as the square root of 7. But we still have this square root of k squared. Now, the rule for exponents is to divide exponents by 2. Okay, divide your exponents by 2 because you're taking a square root. So 2 can go into 2 how many times? Just 1. So that means 1k has to come on the outside. So your answer is 2k square root 7. All right, now looking at number 6 here. Number 6, I'm going to rewrite it as the square root of 112 and the square root of 8. All right, now we can look at this variable first. The a doesn't have a visible exponent. So when there's no visible exponent, it's understood to be a 1. With that being said, 2 cannot go into 1. So that means that this a is never going to come out of the radical. But let's focus on this 112. We know that 112 is divisible by 4. So if we do 4 into 112, it's going to be 28. So we can rename this as 4 times 28. The square root of 4 is 2 square root 28. And I just told you the a is not going to come out, so I'm going to leave it under the radical. From problem number 5, we know that 28 can be broken down into 4 times 7. So now this is 2 square root 4 times 7. Bring down the a. The square root of 4 is going to be 2. So it's 2 times 2 square root 7a. 2 times 2 is 4 square root 7a. Okay? And then we're going to just try one more. I only plan to do 6, but let's try one more. Okay? Say we have the square root of 98, a to the 3rd power, b to the 4th power, and c. We're going to start by focusing on the number. So I'm going to put square root of 98, and then I'm going to put my variables together. Okay? Now, when you're looking at 98, you're probably thinking 4, but I'm going to think larger. Okay? And I know that half of 98 is 49. So I'm going to do 49 times 2, because 49 is a perfect square. So the square root of 49 is 7. 7 comes out, and the 2 stays under the radical. Now, I'm going to come over here and look at my variables. 2 can go into 3. 2 can go into 3 one time with the remainder of 1. 2 can go into 4 2 times with the remainder of 0. 2 cannot go into 1. So since 2 can't go into 1, I know the c has to stay under the radical. So here, for my a, 2 could go into 3 one time with the remainder of 1. 1 comes out, 1 stays in. So whatever the remainder is, that tells you how many of that variable has to stay in. For my b's, 2 can go into 4 2 times. So 2 b's comes out. The remainder is 0, so there are no b's on the inside. For your c, 2 cannot go into 1, so the c has to stay in. So now we got to put this together and make it your final answer. The terms that are on the outside will come together and stay outside. 7a b squared. The terms that are on the inside will stay together on the inside. Now, you can go back and watch the video as much as you need to. If you need to watch it at home, you have the little handout with the instructions, so you can watch it at home. Feel free to watch it and practice as much as you need before I see you guys again on Monday. Work hard today and Friday and make Ms. Watts very proud.